All right, ladies, here's part 2 of your notes, and we're going to start by reviewing some solving that we did back in the fall. The first one is solving a square root equation and solving an absolute value equation. When we did these in the fall, we used a method we called unwrapping or undoing. So let's crunch through these and make sure we remember the steps that are involved. When you start these problems, what you want to do is isolate the square root. That means you're going to get rid of all of that stuff that's outside of the radical, outside of the square root. So we're going to start this problem by subtracting 2 from both sides. You can show that, or you can just do that part in your head. Okay. Once you've isolated the square root, you need to eliminate the square root. You eliminate the square root by squaring it. You just square both sides. When you square the left side, the square root, this thing right here, just disappears. It's gone. And when you square the right side, 5 squared is 25. Okay? And once you've done those 2 things, you now have something that's really simple. Just go and solve this one. Show whatever work you need to show. You get x equals 13. Okay? That's the method we called it unwrapping. All right? Solving an absolute value equation, similar method, we want to isolate the absolute value with all that stuff in it. So we're going to add 1 to both sides. And now we need to remove those bars. And take just a second to think, see if you remember what happens, what you also have to do whenever you remove those bars. And the answer is you have to put a plus or minus on the other side. So we're going to take the bars away. We get the argument from inside there, 3 minus x. And on the right-hand side, instead of just a 4, we get plus or minus 4. Now, people had a couple of different ways that they wrote this down, but I think the first way I showed you was just to write 3 minus x equals 4. We had the word or there, noticing or acknowledging that there are 2 different paths to go down here. And now you have 2 equations to solve, but they're fairly simple equations. Two answers, x equals -1, x equals... Oh, I made a mistake. 4 plus 1, we can back up. 4 plus 1 is 5. Don't treat all sitting there going, what the heck? So let's fix all of these. It should be a 5 and 5, that'll be 2, so -2. And this will be a 5 and -8. There's my 2 answers. And this time, the right answer is -2 and +8. Okay? All right, so that's one technique that I want to make sure you know how to do. The second one is to remember how to solve an equation by factoring. So this is a quadratic equation, and it's nice quadratic form, or we call it standard form. It's set it equal to 0. It's already equal to 0. And the method I want us to review is by the factoring method. There are 3 kinds of factoring. You should always look for GCF first. Difference of 2 squares is easy because there's only got 2 terms instead of 3. And the one that we tend to do the most often and have the most trouble with is guess and check, and that's the one that we're going to use for this example right here. So first of all, it has to say equals 0 in order for this method to work. You put the 2 sets of parentheses, you make a reasonable guess for your first term. 2x times x has to equal 2x squared. You need to put the 3 and the 1, or the 1 and the 3. I think in this case it's going to be 3 and 1. And I just want to remind you about the signs. Remember that this actually has to equal -3, so 1 plus and 1 minus. Don't forget that you need to actually check it. When we were doing this before, most of y'all got pretty good at doing the check in your head, but let me just write it down here. That's 3x, that's minus 2x. It's almost right. It gives me a 1x, and I want it to be a -x. So the right number but the wrong sign. So I'm just going to go back in and change the signs, and that'll give me the correct answer. So this will be a -3 and a +1. When you do guess and check, there's a few of you doing something called the box method or Virginia Tech method. Those are all perfectly fine. All right, once you've got it factored and it equals 0, then you're using what's called the zero product property. The zero product property says to take each of the separate factors and set them equal to zero. That's the only way that I'm going to get the answer 0 is if one of the factors is 0. Do a little work, add 3, divide by 2. We get 3 halves, and this one subtract 1, and we get -1. So that's solved by factoring. Okay? Those of you who have your quadratic formula program in your calculator might hit pause for just a second and try your program with A equals 2, B equals -1, and C equals -3, and double check that you get the right answer. You could also have solved this quadratic formula by using quadratic formula. Okay, that would work fine. All right. And now before we jump into solving any more equations, I want to just look at some of the possibilities. We've done this graphically already, but I want you to kind of think about the different possibilities. When you are solving an equation that involves a parabola and a line, it's possible to have 2 solutions. The parabola could open up or it could open down. It could be a tilted line or a horizontal line. Is it possible to have a parabola and a line and only have one solution? Is that a possibility? And the answer is yes. There's a couple of ways. One, I can put a horizontal line that just touches that vertex. Okay? And there's another way you could get only one solution. And that would be a vertical line. There's actually a third way, but it's really, really hard to draw, so I'm not going to put it up there. Okay? Is it possible to have a parabola and a line that has no solution? That is, that they do not touch at all. And there are several ways to do that. One of them would be to put a horizontal line down here under the vertex, or if it opens up, opens down, you can do it the other way. And another one would be to put one that's tilted, but that is slanted in such a way that these are never going to meet. Now, someone usually says, well, we could put a vertical line there. And my answer to that is yes, but this expands and starts to move out, and at some point that vertical line is going to touch it. So that vertical line would have one solution, not no solution. Okay? What if we had a system that involved 2 parabolas? Can you draw one parabola and draw a second parabola on there that has that's going to create 2 solutions? And there are several ways to do that. You can just put one that opens down just like this. You can put another one that opens up, but that is a little bit wider than that. And someone drew one yesterday that looks kind of like this. See if I can get this right. It's upside down, but it kind of over at the side. So it intersects in 2 points. All right? Can you think of a way to draw 2 parabolas so that they intersect at exactly one point, one solution? And the most common one is to have their vertexes meet. That's the most common one, okay? There is another one, if the 2 parabolas are sort of alike and they cross like this, it's almost like these sides are kind of running parallel and they won't meet again, okay? And can you think of a way to draw 2 parabolas so that they never meet, never intersect? Okay, and the easiest one is having one open up and the other one opening down, either directly below each other or beside each other. That's the easiest one to think of. There is one other one. You have kind of a wide one, and then you put sort of a skinny one in the middle like that, and they would never meet. Okay? What I'd really like you to do is hit the pause button right now and see if you can draw me at least one sketch for each of these situations. Absolute value in a line. Don't do 2 absolute values. Do absolute value in a line and square root in a line. So you want an absolute value in a line. You want a square root in a line. So hit pause. Okay, now hopefully you try this on your own and you're not just copying mine. So I'm just going to give you several options here that might work. Absolute value in a line, or absolute value in a line. A couple of ways to get the no solution. One would be to do a horizontal line, and another one would be to draw that line parallel to one side of your absolute value. Remember, we have square root functions that can either increase or decrease. Okay? So here's an increasing one, and I could draw a line like that, or a decreasing one and I could draw a line like that. Okay? It's pretty easy to do one solution. Just slap a line through there, and again, increasing or decreasing. Horizontal, vertical, tilted, and no solution. Also, you could do a horizontal line, or if you go over here to the vertical line over here, that would be no solution. Okay? So we have all these possibilities: 2 solution, 1 solution, or no solution. All right? All right, so let's jump in and solve a few systems. Systems, we have 2 equations, and instead of graphing them, we are solving them analytically. It says here to check your solution by graphing. That's one of the things you can do for your homework tonight. I'm not going to stop and do that in the notes for class today. This is the exact same method that we had earlier. We're going to take y1, we're going to set it equal to y2. Square root of 2x minus 1 equals 4. And hopefully we're going to have an equation that we then know what to do with. In this case, we're going to square both sides. And then add 1 and divide by 2. And even though we got kind of an unpleasant x, that fraction 17 over 2 is not that bad, because guess what all of the y answers have to be for any problem that we do for number 1. That horizontal line y equals 4. So our point is 17 over 2, comma 4. If you check 17 over 2 back in the original equation here, you would still get 4. That's also another good way to check that you're getting the right answer. Okay? An absolute value and a horizontal line. So here's the absolute value, and it has to equal that horizontal line. All right? So we're going to isolate by subtracting 3. And now we're going to get rid of the bars by just taking them off, and when you take them off, you have to put plus or minus on the other side, plus or minus 4. Okay? I'm going to write that as 2 separate equations. And then solve each one of them independently. X equals 8, x equals 0. So we have 2 answers now. This is an equation of this absolute value and this horizontal line are going to have 2 solutions, 2 points of intersection. Okay? So you have to have an x and a y for each one of them, but that's easy. What's y for everything in this problem? It's going to be 7. Okay? Typically, I want you to write your answers in point form, so the point 8, 7 and 0, 7, but this is actually an acceptable way to write your answer as long as you have both of them there. Okay? Number 3, we have this time a line. Y1 is a line, Y2 is a parabola. Okay? So we set the line equal to the parabola. Now, we did not solve any of these equations back in the fall. When we looked at equations that had x squares in them, they're called quadratics, they always said equals 0. We were doing these problems in the fall to find the x-intercepts or find the zeros. So the only thing that's different about this equation is it doesn't say equals 0. So the very first thing you have to do is make it equal 0. Now you can move everything to the left or everything to the right. I tend to move everything so that the quadratic term, the square term, has a positive coefficient. Just because if I'm going to factor, I do a better job if that is not a negative number. So I'm going to add 2x and I'm going to subtract 4. You do that at the same time, like this, so that my left side is 0 and my right side says x squared plus 6x. Okay? At this point, you're going to have some options. Sometimes you can solve by unwrapping. It doesn't work on this problem because there's an x squared and an x. You can solve by factoring on a lot of the problems, and you can always use the quadratic formula. Be aware that you will have to do some of these problems without your calculator. So make sure you're practicing the quadratic formula without your calculator, or that you're really, really good at factoring. Okay, so this is GCF factoring. And then I set up my 2 different paths. I should say x equals 0, x equals negative 6, x equals negative 6, and then I have to get my y value. Now this time y is not a horizontal line. So I actually have to plug these numbers in. You can pick whichever one's the easiest one. So this one is going to be easier to plug into. We can use to practically do that one in our head. Y1 equals -2 times 0 plus 4, which gives me y equals 4. And I think you can also see that if you use this one, you get 4. You would get 4 for that as well. The -6, y equals -2 times -6 plus 4, which gives me 12 plus 4, which is 16. So my two answers are 0, 4 and -6, 16. So what I really want you to practice when you're doing this homework is I want you to practice also graphing this. Go back to this very first one and graph that and make sure that your points of intersection match. Okay. You also could practice your quadratic formula from right here with A equals 1, B equals 6, and C equals 0. Okay? All right, so another parabola and a line. 2x squared plus 3x minus 1 equals 5x plus 11. When you have a quadratic equation, you need to make it equal 0. That has got to be your first step in order to factor or to use the quadratic formula. So I'm going to subtract 5x, and I'm going to subtract 11 from both sides. This time I moved everything over to the left because, as I said, I prefer for my leading coefficient there, my A value to be positive. All right? We're looking for things that make our life easier. I need to solve this. You can factor it. You can use the quadratic formula, but you notice that everything is divisible by 2. So if you will just start by dividing everything in this problem by 2, whatever method you get will be a little bit easier. You'll have slightly smaller numbers. Okay? So for the problems tonight, pretty much I've given you things that are not difficult to factor. They're not going to be any of those. We had some back in the fall that were a little bit hard to factor. You had to really work at it, and I'm not planning on giving you anything that's quite that nasty. Okay? So there's my 2 factors. And then that takes me to x plus 2 equals 0, or x minus 3 equals 0. When you're doing this in the fall, many of you could go from here and just go straight to the answer. Got the 2 answers, x equals -2, x equals 3. And once again, it's easier to plug those numbers into the linear problem, so that's the one I'm going to plug them into. 5 times -2. Now put those calculators down. Practice this without the calculator. The arithmetic's not that difficult. And then you have to do it for the second point as well. And then if you want to use your calculator, you can put this in your graph Y1 and Y2 and look for the points of intersection. Actually, right? I'm going to have to erase this a little bit. So, covered up my next one. Okay, this time I have 2 parabolas. Okay, I have a parabola that opens up, and I have a parabola that opens down. Start by setting them equal to each other. Okay, it's a quadratic because it's got an x squared, so we need to move everything to one side. My preference would be to move it to the left. I'm going to add the x squared to both sides, and I'm going to subtract the 3. Subtract the 3. And I get 2x squared minus 8 equals 0. Now, this one, you could actually solve by any of the methods that we have learned. You can solve this by factoring. First, divide everything by 2. And this is difference of 2 squares. Okay. You can solve this by the quadratic formula. A equals 2. B equals 0 and C equals -8, or A equals 1, B equals 0, and C equals 4. You can do that. But you could also solve this by undoing. Since it's got an x squared and it doesn't have an x, so I just want to review that method. Okay, we're going to add 8 to both sides. Then divide both sides by 2. And then I'm going to take the square root. And when you take the square root, you have to put a plus or minus. So we end up with two answers, x equals 2, x equals -2. Plug them into either one that you want, either equation. I'll probably use this one because it's not a minus x squared, it's a positive x squared. So y is 2 squared minus 5. 4 minus 5 is -1. And remember, when you plug in a negative number and you square it, you need those parentheses. I've run out of room. There's a -5 on the end of that. Okay, and that also gives me 4 minus 5, which is -1. So I have 2 points of intersection. Okay. All right, this one looks like it's going to be horrible because it's two parabolas again. -x squared plus 2x minus 4 equals x squared minus 8x plus 4. It's just got lots of terms. And again, we want to start this problem by getting everything over to one side or the other, so that one side equals 0. So I like my x squared to be positive. I'm going to add x squared, I'm going to subtract 2x, and I'm going to add 4. Okay? Add x squared, subtract 2x, and add 4. 0 on the left, 2x squared minus an x plus 8. Once again, I've got an equation where I can divide everything by 2. Whatever method I'm going to use, whether I'm going to factor or quadratic formula, whatever I'm going to use, dividing it by 2 will make it easier. Okay? I'm going to go ahead and factor this one. I just feel like the more practice you get with factoring, the faster it'll come. Remember, we're going to have two minuses here because there has to be at least one minus to get the -5, and that last term has to be positive. So 2 minuses, -4, -1. And I think, as I said earlier, by the time we had done this in the fall, y'all got to where you could just write down that that answer was 4 and that answer is 1. Okay? I don't think that either one of these equations is easier, but this negative in front of the x squared causes some people to mess up on their arithmetic, and this doesn't have it, so I'm going to plug everything into that second one. And again, practice doing this without your calculator. You are certainly expected to be able to do this level of arithmetic without your calculator. There's the first point, 4 comma -12, and 1's always a little bit easier to deal with. And there are my 2 points. Okay, practice as much as you can without using your calculator. Okay, I'm going to stop this video right now, and then I'll make a third video for the last bit of this.